Okay, so our goal today is to understand and interpret odds and relate them to probability. So for example, let's start with oil and vinegar salad dressing is made using 2 parts oil to 1 part vinegar. So the ratio is 2 to 1. Okay? So what fraction of the dressing is oil? So what fraction of the dressing would be oil then? So first of all, it's ratios oil to vinegar. So 2 out of what? 2 over 1? 2 over 3. You're right. 2 over 3. Because if we're doing, it's a 2 to 1 ratio. So oil is 2, vinegar is 1. Whenever we do a ratio, right, we're doing the dressing. So in this case, the total amount. If this was, for example, 2, I don't know, teaspoons to cups. Cups would be a lot, but maybe you're making a lot of dressing. 2 cups oil, 1 cup vinegar, for example, then it would be a total ratio of 2 over 3. And so you could also talk about, we can use that same idea in probability. If our odds were 2 to 1 for something, then in favor would be, the probability would be 2 out of the total, which is 3. So our key idea is odds express a level of confidence about the occurrence of an event. So the odds in favor of event A occurring are given by the ratio. So P of A is the probability of A occurring. What's this mean here? What do you think that, what's that? Do you remember that? Not an A, right. It's the probability of not A. And once we actually reduce that, what happens is it actually reduces, because if it's a probability of something occurring is 1/8, then not occurring is 7/8. When we actually reduce that, the odds become 1 to 7. So really we're writing it as A to not A. Okay? So how many times does A occur compared to how many times does A not occur? So when we actually simplify that ratio, this is what it becomes. And then we could also look at odds against. So odds against A happening would be, okay, how many times does A not happen compared to how many times does A occur? That would be the odds against. Right? So whatever one you want, if you want 4, the 4 goes first compared to the against. Whereas if you want against, the against, how many times does it not happen compared to how many times it happens. So it's going to simplify to this ratio of M to M. We always reduce our ratios. If we know our odds are N to M, then the probability of N happening would be, or M happening, M over the total. And the total would be the sum of the two, right? Because if we have A, the number in A plus the number in not A, it's the same thing as the number in the universal set. Do you remember that? So the total times something occurs. Oh, and this one's really important here. I'm going to highlight this. So the probability of something not happening is 1 minus the probability of it happening. Right? Because our odds always add to 1, total 100%. You can't have more than 100%. And so the probability of rolling 6 plus the probability of not rolling a 6 would be 100% total, right? Because not rolling a 6 would be 5 out of 6 times. Rolling a 6 is 1 out of 6. The total is 1. Okay, so let's look at some examples. The odds in favor of Marcia passing her driver's test on the first try is 5 to 3. Okay, so what does that mean? So if she takes the test, 5 times she will pass, because this is the odds in favor. The odds in favor of passing. So 5 times she will pass. Number of times she is expected to pass. And the 3 would be what? The time she won't pass. So number of times she won't pass or fail. You can say it as, okay? So if the odds of passing in favor of 5 to 3, determine the odds against passing. What would be the odds against passing? 3 to, not 8, 3 to 5. It would just be the reciprocal. If the odds in favor are 5 to 3, the odds against are 3 to 5. So what is the probability that she will pass? So the probability she'll pass, well, how many times is she expected to pass? 5 times out of a total number of tests. How many total tests would that be? 8, the sum of the two. So 5 eighths. 5 out of 8. Easy? So your total, when we want our total, remember it's favorable over total, we would add those two together. Bailey holds all the hearts from a standard deck of 52 cards. He asks Morgan to choose a single card without looking. Determine the odds in favor of Morgan choosing a face card. So we want odds in favor of a face. So we need the number of face cards compared to what? The number of total cards. Remember, it's always, if it's in favor, A to not A. So what would be not A in this case? The number of not face cards. Okay, how many face cards are there in the 13 cards that she holds in her hand? She's holding all 13 hearts. How many of them are face? 3. Jack, Queen, King. Yeah, there's 3. How many are not face? So then there would be 10, because 3 of them are. 3 to 10. Now, can we reduce that? No. If we can, we must reduce. No, it's not a probability, right? It's just the odds in favor. So 3 to 10 odds means 3 times she will pick out of all 13, because out of 13 actually is a total. The probability would be 3 out of 13. What? Yeah, 1 to 2 odds. So, like, if your odds were 1 to 2 of something happening, half the time you would get it, and half the time, right? Like, only half the time it would occur. Or a third of the time, I should say. But you're twice more likely to get the second than the first, I should say. There you go. A computer randomly selects a university student's name from the university database to award a $100 gift certificate for the bookstore. The odds against selecting the odds against the selected student being male are 57 to 43. Let's interpret that. The odds against, okay, the odds against being male. So what does that mean? The 57 is what? If you're not a male, you're against a male, what are you? Female. So these are not males. 57 not males. Or females to males. Okay. Determine the probability that the randomly selected university student will be male. So what would be the probability that you're male? Well, favorable over total is the formula for probability. How many times will you be male? What are the odds of being male? How many of them will occur? How many males occur? 43. And how many total people are there? So to get our total, we always add those together. What's 57 plus 43? 100. So 43 out of 100 or 43% or 0.43. Okay. A hockey game has ended in a tie after a 5-minute overtime period. So the winner will be decided by a shootout. Coach must decide whether Ellen or Brittany should go first. Coach will prefer to use her best score first, so she will base her decision on the player's shootout records. Okay, so who should go first? So let's go with the probability of Ellen scoring. How do I get the probability of Ellen scoring? Well, how many times did she score? How many goals has she scored? 8 in the last, total of what? Yeah, attempts means how many total shots she's taken, right? So 8 out of 13, which is what? Someone did that. Point what? 6.1. Oh, 61.5% or 0.615. Okay, what's the probability of Brittany? Would be goals scored, 10 out of, this one's almost too easy, 17, that equals 0.58. So who should go first? Yeah, so Ellen should go first. Now I could ask you a few other questions. What if I asked you, what's the odds? Let's add an extra question here. What's the odds in favor of Ellen scoring? Okay, can you complete that one? And then I'd like you to find the odds against Brittany scoring. Okay, find both of those. Give that a try. Okay, so odds in favor of Ellen scoring. So how many times will she score? 8 out of, 8 compared to, how many times will she not score? 5. 13 minus 8. So 5 times she would actually miss the net. So the odds are 8 to 5. Odds against Brittany scoring. So how many times will Brittany not score? 7 compared to how many times will she score? 10. Remember that the sum of your odds will then equal your total attempts. Okay? So that's a really short lesson today. So the homework is page 57 to 59 in your workbook. And that is it for today. It's not that bad. It's not bad. It's so fast. This stuff is like, you'll fly through it, I promise. And we have lots of time. 40 minutes.